Good day, everyone. I am Chris Joshua Ambita, and I am here to discuss to you about the Polya's four-step approach to problem solving. Just like other students, do you find solving mathematical problems hard? If yes, follow me as I teach you and how to solve mathematical problems much easier. Before we start, let us reflect on this quote. It is better to solve one problem in different ways than to solve different problems in one way. That is according to George Polya. George Polya was a Hungarian mathematician who made a significant contribution to the field of mathematics. He was born in Budapest in 1887. One of his most significant contributions to the field of mathematics is his emphasis on giving importance to solving mathematical problems by understanding it first. Up until to this day, his contribution to mathematics is still useful in terms of mathematics education. Here are the four-step approach to problem solving according to George Polya. Number one is to understand the problem. Second, devise a plan. Third, to carry out the plan. And lastly, is to review your solutions. Now, let us talk about the first step. In the first step, it is to understand the problem. Here, we can state the problem in our own words for us to better understand it. Next, we can also identify what is known about these problems or the given information and those information that are not implicitly defined or given in the problem. We can also omit those informations that are not needed to solve the problem. Next, and the second step is to devise a plan. Here, we can make a list of all those known information, just like what are the given, what is the formula to be used. If there is no formula to be used, we can create an equation ourselves. Next, the third step is to carry out the plan. Here, we can work carefully and use the equation we have made in the second step and use it in the third step to carry out the plan or to solve the problem. Here, we can realize that what we have created in the second step is not useful or not correct. Therefore, we can go back to the second step and then create another equation and then carry out the plan again. Lastly, if we have already found the right answer, we can now review our solution. In this step, we can now interpret the solution in the context of our problem that we are solving. We can also ask ourselves if there are any generalization of the solution that could apply to other problems also. Is everything clear? Now, let us proceed to challenging what you have gained throughout my discussion. Let's try and learn. It's seatwork time. Example number one. What is the 30th decimal digit in the decimal representation of 1 over 11? Now, we can use the Polya's four-step approach in solving this problem. In the first step, as we recall, the first step is to understand the problem. In this problem, we need to find the 30th digit after the decimal point of the decimal expression of 1 over 11. Let us express the fraction 1 over 11 into a decimal point and look for a pattern. This pattern will enable us to determine what is the 30th digit in the place after the decimal point. In the second step, we need to devise a plan. In this problem, we can divide 1 by 11 in order to find the decimal expression using your calculator or by using long division method. We can also create a table and then look for a pattern. In the decimal representation of 1 over 11, we can find that it is 0.0909 0909, and so on. We can find in the decimal representation that it takes two numbers, which is 0 and 9, and then repeating it infinitely. And that is the pattern. The pattern is repeating 090909, and so on. In this pattern, we can realize or we can see that it takes two numbers. Therefore, at every two number, it will be 9. So every multiple of 2, it contains the number 9. In this case, 30 is a multiple of 2. Just like 2, 4, 6, 8, 10, 12, 30, and so on. All even numbers are all multiples of 2. Therefore, since 30 is an even number, it is also multiple of 2. That's why it contains the number 9. In order to check, we can create a pattern. We can see in the presentation that the first digit is 0, and the second digit is 9, and the third digit is 0 again. The fourth digit is 9. We can see that all those even places contains the number 9. And in the table, the 30th digit is 9. Therefore, our answer is correct. We can now generalize or make an interpretation based on the table we have created. Hence, based on the table, the 30th digit in the digital representation of 1 over 11 is 9. Isn't it amazing? Isn't it easy to solve right now? If yes, let us proceed to our second problem. Example number 2. There are 364 first grade students in Park Elementary School. If there are 26 more girls than boys, how many girls are there? First, let us understand the problem. The problem is that the Park Elementary School has a total of 364 first grade students. So there are 364 first grade students. And we need to figure out how many girls are there if there are 26 girls more than boys. We can use B as the number of boys, and B plus 26 is the number of girls. Why? Because the problem states there are 26 more than girls than boys. Therefore, we can add 26 to the number of boys in order to get the number of girls. Hence, we can use the equation B plus 26 is equal to the total number of students of first grade students, which is 364. In the third step, which is to carry out the plan, we can now simplify the equation that we have created in the second step, which is the common variable, which is b plus b. And in this case, if we add b plus b, we get 2b plus 26 equal to 364. In an equation, we can isolate all the variables in the left and all the constant to the right. Therefore, we can subtract 26 on both sides in order to isolate 2b in this equation. So 2b is equal to 364 minus 26. That will give us 328. Now, in order to get the number of boys, we need to divide both sides by 2 in order to get the value of the variable b, which is the number of boys. Dividing using our calculator, we get that the number of boys is equal to 169. Now, we know that the value of b, which is the number of boys, is 169. And in order to get the number of girls, we add 26 to the number of boys in order to get the number of girls. Therefore, 169 plus 26 is equal to 195. And this is our answer. The number of girls is 195. Now, we can now interpret our answer and review our solution. Since B represents the number of boys, 169 plus 195, which is the number of girls, we get 364. And that is the total number of all first grader students in Park Elementary School. And there should be 26 girls more than boys. And if we subtract 195, 169, we get 26. Therefore, our answer is correct. As you can see in the presentation, that is the simplified version of our application of the Polya's four-step approach and our second problem. You can take a screenshot and then study it at your homes. Are you still there with me? Now, let us proceed to the third problem. One number is 7 more than another. Twice the larger is equal to 4 times the smaller, decreased by 2. Find the two numbers. Now, let us understand the problem. We are looking for two numbers, wherein one is more than another, and twice the larger is equal to 4 times the smaller, decreased by 2. In order to simplify the problem, we can also use a variable in order to write an equation. We can let x as the smaller number. On the other hand, we can add 7 to variable x in order to get the large number. Why? Because the problem states that one number is greater than 7 than the another. The another there is the smaller number. And x plus 7 is the larger number. In the problem, it states that twice the larger number, which is x plus 7, the larger number, is equal now to 4 times the smaller number. Therefore, this 4x decreased by 2. So we subtract it by 2. Now, this is now our equation. In order to simplify our equation, we can distribute 2 to the quantity of x plus 7. So 2 times x is 2x, and 2 times 7 will give us 14. And copy. Now, we can see that there are variables of x on both sides. Therefore, we can isolate the number of 4x to the left. We can subtract 4x on both sides. And that will give us negative 2x. And here we can also subtract 14 on both sides in order to isolate the constant to the right. That will give us 0. And this 4x minus 4x is also 0. And then negative 2 minus 14 will give us negative 16. Now, we can divide both sides by negative in order to get the value of negative of x. Negative 2 divided negative 2 will give us 1. So we x is left here, and then negative 16 divide negative 2 will give us positive 8. Now, we already have the value of the smaller number, which is 8. So our smaller number is 8. And in order to find the larger number, we add 7 in, and that will give us 15. Now, we already have the two values, or the two numbers that we are finding, which is 8 and 15. We can now review our solution. We all know that 15 is 7 more than 8. If we add 7 plus 8, that will give us 15. And twice 15 is 30. And 7 times 4 is 28. So 30 less 2 is equal to 28. And that will give us that our answer is correct. This is also the simplified view of our application of the Polya scoring approach to problem solving. Now, let us proceed with our fourth problem. A basketball team won 2 out of their last 4 games. In how many different orders could they have 2 wins and 2 losses in 4 games? Let us understand the problem. There are many different orders. The team may have won 2 straight games and lost the two. That will give us win-win, loss-loss. Or maybe they lost in the first 2 games and won in the last games, like LLWW. Of course, there are many other possibilities, such as WLWL. Now, let us devise a plan. In this problem, we can use the combination formula to find the number of possible combinations of wins and losses. We can make an organized list of all the possible orders. The combination formula is NCR is equal to N factorials all over R factorial times the quantity of N minus R factorials. The N there is the total number of objects in the list, while R is the number of chosen objects from the set. To carry out the plan, we cannot substitute the given values. There are a total of 4 numbers of objects in the list, which is win, win, loss, loss. And then in their 4 games, out of their 4 games, there are 2 losses. Therefore, we can use the numbers as the values are. To carry out the plan, let's substitute 4 C R, which is 2, is equal to N factorials, which is 4 factorials, all over R factorial, which is 2 times N 4 minus R, which is 2 factorials. For those who don't know, factorial works as 4 times 3 times 2 times 1. We multiply the number until 1. All over 2 times 1 minus 4 minus 2, which is 2 factorials. Here, we can cancel out 2 times 1, 2 times 1 from the numerator. And that will give us 4 times 3, which is 12. And then 2 factorials, which is 2 times 1, equal to 2 and then divide 12 by 2, that will give us 6. Therefore, there are 6 possibilities of all the orders of 2 losses and 2 wins in their games out of 4. Here are the possible combinations: win, win, loss, loss, win, loss, win, loss, or loss, win, win, loss, 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 win, win, loss, win, loss, win, or win, loss, loss, win. That are the 6 possible combinations of 2 loss and 2 wins. To review our solution, the list has no duplicates, and the list considers all possibilities. There are 6 possible combinations in which the basketball team can exactly have 2 wins and 4 losses out of 4 games. Therefore, our answer is correct. That is also the simplified view of our application of the Polya sportsmanship approach in solving this problem. Now, we are on our last problem. Example number 5. Farmer Brown has many animals in his farm. He has 72 chickens, which make up 60% of his total animals, and the rest of his animals are sheep. How many legs in total do his animals have? Now, let us understand the problem. The problem tells us that we are trying to count how many legs of the animals are there in total. The animals were chickens, which have 2 legs, and sheep, which have 4 legs. We can now devise a plan. We will work with an equation. An example of an equation to use is 72, which is the total number of chickens, times 2, which is their number of legs, plus the number of sheep, which is unknown. We can use n to substitute the number of sheep as an unknown, and times 4, which is their total number of legs, is equal to the total number of legs. We know that 60% of the animals is equal to chicken. Therefore, we, if the total number of animals is n, 60% of n is equal to 72. Now, we can rewrite this as 0.60 times n is equal to 72. To get the total number of animals, we divide both sides by 0.60. So n is equal to 72 divided 60, which is 120. Therefore, the total number of animals is 120. Subtracting 72 to 120, that will give us 48. And that is the total number of sheep. Now, we can now substitute to our equation. Now, let us carry out the plan. We already have the number of sheep, which is 48. And now we can substitute to our equation. 72 times 2 plus 48 times 4 is equal to what? 72 times 2 will give us 144 plus 48 times 4, which is 190. And that will give us 306. Now, 336 is the total number of legs of all the animals of Mr. Brown's in his farm. There are 144 legs of chickens. There are 192 legs of sheep. And adding both numbers will give us 336, which is the total animal legs in this farm. To review our solution, we can multiply 0.6 times 120, which is 72. That is the total numbers of chickens. And the 0.4% and the 40% or the 0.4 times 120 is equal to 48. And that means that our answer is correct. And we're done for today. Thank you everyone for listening and God bless us all.